Hi guys, before we actually go into the lesson, I first have to say I don't know what happened last time. Apparently my face cam was blocking a small part of what I'm writing and I'm not aware of that. But this time hopefully I've got it fixed and I won't write in the place my face cam is. So let's get straight to this then. There we go. Okay, so today we're going to be talking about ionic bonds. Yesterday we talked about covalent bonds and how they're formed between nonmetals and nonmetals. Well, a nonmetal and a nonmetal. Today, ionic bonds are formed between a metal and a nonmetal. So basically, a nonmetal always wants to lose electrons and form a positive charge. Actually, sorry, a metal always wants to do that. So if we take a look at sodium, for example, sodium has one valence electron, and it'll be easier for it to lose this valence than to gain seven other ones. So basically, typically sodium, its stable form, it will form a charge of positive 1. So metals form positive charges because they want to lose their electrons. And nonmetals, which is mostly focused on the right side of the periodic table, most of them, apart from the noble gases, want to gain electrons and form negative charges. Take chlorine. Chlorine has 7 valence electrons. So there we go. Chlorine has 7 valence electrons. It'll be easier for it to just gain another one rather than lose all 7. So basically, typically chlorine will form a negative 1 charge. So the basics of why ionic bonds happen is, for example, in the last lesson we talked a teeny bit about that, but this time I want to extend more. So basically, wouldn't it be simpler if sodium just donates this electron to chlorine? So if we take a look at sodium with its 1 valence electron and chlorine with its 7 valence electrons, oh come on, that's 2. Anyways, sodium, it'll be easier if sodium would just give this valence electron to chlorine, because then chlorine would get 8 in its in its outer shell, 8 valence electrons, and sodium will lose the 1. They will both be stable. And now, since sodium lost 1 electron, it's going to form a charge of positive 1. And chlorine, since it gained 1 electron, it's going to form a charge of negative 1, or 1 negative. So there we go. And now, this is why they bond, because one atom donates an electron to another one, so they sort of fuse together and bond. Okay, this compound that we're talking about here is sodium chloride, otherwise known as salt, table salt, like the salt we eat. Yeah, that salt. So it's a very typical example of a ionic bond. You might remember from last time, we did this thing called the Lewis dot structure, where we, draw lines when electrons are shared. Now, what about the Lewis dot structure for ionic bonds? Last time we did it for covalent or molecular bonds. So for ionic bonds, it's quite simple. Of course, still my advice is start with the Lewis dot structures of the various atoms, and then see, for example, in this case, sodium will donate an electron to chlorine. But the real Lewis dot structure will be this. So basically, we write the finished state, not the starting state. This is like the starting state, and after the donation, this is the finished state. And the one with the negative charge is encased in parentheses. So negative 1 or 1 negative, whatever you want to do, it's fine. And then write the charges. So this is how we do Lewis dot structures for ionic bonds. And if there are, for example, let's see, oxygen with its 6 valence electrons, and let's 2 hydrogens. So I'm just looking for the correct valence number, but inadvertently I picked water, H2O. Why didn't that? There we go. So basically, water is. Wait. My bad. I'm sorry. I picked a covalent bond. Let's see. Let's actually pick a. Actually, yeah. So, sodium oxide. So again, it's oxygen with its 6 valence electrons and 2 sodiums. So in this case, we realize that both sodiums, well, whatever. So both of them will want to lose 1 electron, and oxygen will want to gain 2 electrons. So both sodiums, in this case, will want to donate 1 electron to the oxygen. So in this case, each sodium will have a charge of +1, while the oxygen, gaining 2 electrons, will have a charge of -2. So in this case, we don't write 2 sodiums. We put a 2 in front of the sodium, and we write the charge of each individual sodium. So this is how we handle Lewis dot structures when there are more than 1 atom involved. So of course, in order to master these Lewis dot structures and these bonds, practice is needed. But for the case of teaching and videos, I won't be doing a lot of practices. Anyways, one last thing before we end this video. Metallic bonds, which is formed between like 2 metals. That kind of bond, as far as I know, haven't been that important in like the 6th grade curriculum. And actually on my tests, on all of my tests throughout 6th grade, I only got 1 single question on like molecular bonds. Sorry. Metallic bonds. Molecular bonds, I got a lot of questions on that. So I won't be covering that a lot, but I will say that it's formed between a metal and a metal, and the electrons are shared. So basically, because this is still mainly a 6th grade course video, I won't be going very deep into that. So I hope you forgive me. But basically, that's it for the video. Hope you've learned a lot.